Hello, everyone. A warm welcome to all the students and parents who have, taken their time out to join this Code Talk. And my name is Ashutosh Gupta, and I am hosting today's Code Talk with our guest Rohit Raju. Rohit is currently the director of product at Codeyoung. He's heading the team of product and technology at Codeyoung. Before Codeyoung, he was with Paytm and Practo. Paytm is one of the India's largest payment app, and Practo is one of India's only app. Is one of the largest app where you consult with doctors. And Rohit overall has about 7 years of experience in building technological products across healthcare, e-commerce, advertising, travel, and now education. He's a specialist in building data science and machine learning features, and he likes to spend his time as a data scientist on Kaggle to solve some problems. So I think first of all, again, welcome Rohit. Uh, I would like to know how is it to be on Code Olympics and in the third episode of Code Talk.
Yeah, thank you. I think thanks for the good introduction, Ashutosh. Yeah, I think it's great to be here, right? I think Code Olympics, I think amazing what we've seen. I think 400 kids participating from around the world, and like we've been seeing the projects, such amazing stuff being given by the kids in the community, and
Yeah.
500 projects in the last 1 month, and that's just amazing what you guys have done. So yeah, I'm super excited to be here to talk to everybody here about any. I think we got a lot of interesting questions from the registration. So yeah, so super excited to talk to everybody here.
So yeah, I think without any further ado, uh, so as you all know, today's Code Talk topic or the title is building for the future. What it means is that what are the upcoming technologies in various industries which will affect all the aspects of our life. To begin with, for example, 20 years ago, nobody would have imagined that a student sitting across uh, on the other side of the globe is learning from a teacher in India, right? And today, that is very much a possibility, and not only a possibility, it's actually a normalcy, right? And technology has not only affected us in terms of how we learn and how we shop, it has affected us in every way, in terms of banking, finance, in terms of healthcare, and perhaps it will be affecting us furthermore in the coming future, right? And that's what we want to this talk is going to be about, right? So I think first of all, for all the students, those of you have many of you had sent us questions, and we are going to definitely talk about them. But if any of you have any more questions, you can send us in Q&A, right? So now coming to the first question of today's evening. So what do you think, Rohit, will be the possible upcoming changes in the industries which have had not had any technological advances? I mean, for example, the technologies like so the industries like agriculture have not been affected at all, like not much by the tech boom, as we say it, right? And why do you think they haven't adopted so far?
Yeah, that's a good question, right? So these are different revolutions which happen. So in the 1800s, the industrial revolution happened, right? And with the industrial revolution, what happened was human labor and human intensive activity got replaced by machines, right? So machines started doing replacing human labor, right? Because it was more efficient and it could get things done much more quicker. So mass production started. Now in 1990, the internet revolution happened, the digitizing revolution happened, with the internet and the World Wide Web, and a lot of companies and a lot of businesses have started by which are being powered by the internet, right? And I would say a lot of industries now have gone through some level of digital transformation. But I think we have some exciting times ahead where I think we'll go much more deeper, into transforming into very specific industries. Like you mentioned, agriculture is one space where technology will play a major driver, in the next coming years. The other thing which I feel, is education. Right, education has transformed a lot in the last 5-6 years. Now if you're in any corner of, let's say, even Africa, but if you have a phone with an internet connection, then you can always attend a lecture from a Harvard professor sitting in USA, right? It's possible now. We are all sitting here on a Zoom webinar, talking to people around the world. So that is how sort of education is transforming. Education has transformed a lot, with the internet age. The other thing is healthcare. I think healthcare is going to play a very, very big role in the coming future, where technology will drive a lot of healthcare activities and drive a lot of change in healthcare, right? And also with agriculture and some parts of manufacturing as well. Manufacturing is also slowly getting transformed. Even about 5-6 years back, if you take your car for service, the mechanic sort of gets into working on your car, right? But nowadays, if you take your car for service, they just connect your car to a system, and then they see the laptop for diagnosis of what all they should be checking in a car. So that is the age we're entering in, where software is primarily driving a lot of industry. So it doesn't really matter that what you kids want to do in the future. It could be anything, any stream. But knowing how technology works, knowing how you can empower what you do with technology, could be very, very helpful, very, very defining in the next coming years.
Yeah, I think that's a great answer. I think since we talked about a lot of new things happening in terms of technology and how it has started to affect us, right? One of the very mature students at Codeyoung has sent a question, which is basically, what do you think? For example, in current, in industrial age, we had various branches of science, right? Civil engineering, chemical engineering, mechanical engineering. But we are seeing that with the tech boom, that we are seeing there are much more deeper fields which are emerging out of computer science itself. So what do you think will be the emerging branches in computer science in future?
Yeah, I think that's a good question. I think we got a question here as well in the Q&A. Do you think China will take over AI and the digital world? So I'll try to answer both in probably the best way possible. So yes, so computer science, general computer science is itself a great career, right? And I think whoever asked this question is talking from a career perspective on what can we do with computer. General computer science itself is a very great career where you can program computers and program applications to make it work in certain ways. But if I have to really talk about some very specific specializations, right? I think one is what I think everyone knows about, which is AI, right? AI and machine learning. So artificial intelligence is a very good specialization to do after your computer science. So artificial intelligence in AI in a very broad sense is basically how can I mimic human intelligence or animal intelligence to perform certain functions or perform certain tasks, right? And AI is a very good very good field to get into the future. But my thing, what I see is, at least in the market right now, is that if you really want to get into AI, I think after you finish your graduation from computer science, you should probably go to a specialized master's, probably in a good university, or you should do a PhD from a very good university and work on research, because AI is not just coding. It is actually a much more research oriented, right? Much more research oriented, much more academic oriented. And if you want to work on the real futuristic stuff, like working on Siri or working on Alexa, or any those kind of really projects which are really transforming how people behave, right? So for that, I think a PhD or a master's in AI, which will really sort of put you ahead in terms of AI, right? Just a general computer science graduation would probably not get you meaty, juicy stuff to work on. But yeah, I think a PhD and master's is definitely there. So yeah, so AI is I think one good specialization in computer science. The other thing which I feel which I think a lot of people don't know, is data engineering. So data engineering is actually really, really big now. A lot of big companies are facing problems with handling data, right? If you look at Facebook, Facebook has billions of users, right? And billions of users are coming on the application and doing multiple things. So Facebook as an application keeps generating everything what happens inside the application, right? So that's like trillions and trillions of data being generated every second. So data engineering is very important because data engineers are the guys who figure out how do I store this data, right? And how do I warehouse this data? So, and how do I create pipelines from this data? So my data scientists or my AI engineers can extract this data and use it for other purposes, or my developers can extract this data and use it for other purposes. So data engineering is, I think it's really good, right? And there are very few engineers out there in the market, to be very honest, that who are really good with managing this humongous amount of data, right? It's very complex, and right now there's a lot of demand for it. I think so. Data engineering is really, really, really good field to experiment, which is completely about how do I store data. If I have to run, let's say, a loop or an algorithm which has to go through like billions of rows of data in under a second, right? How do you do that? So those are the kind of questions which data engineers solve for every day. And very good career in computer science if you want to go into it in the future. Future data is the plate. Everything's going to be around data, right? So data engineering is a really good thing. The other thing is, I think cloud engineering. Cloud engineering has been really good. For people who don't know what cloud engineering is, so cloud engineering has actually transformed a lot of businesses in the last 4 to 5 years, right? Um, for at least even 6, 7 years back, if you had a tech company, you would actually have servers in your office. You would have a server room in your office to sort of manage your servers. But now that is not the case. Everything is cloud hosted, right? And for people who know Amazon, people think that Amazon's primary business is their shopping business, but it's not, right? So Amazon's primary business is actually the cloud business. Amazon Web Services is their primary business. So where they sell cloud services. Microsoft also has Microsoft Azure. Google has Google Cloud. So cloud is actually a very big field in computer science right now. So specializing in cloud has a lot of benefits. You'll understand how how cloud works, and how do you engineer for other companies to sort of use and leverage cloud services. Um, the other thing is, I think quantum computing is also something, I think, a bit more futuristic, but something which will, I think we will be getting there soon. Quantum computing, I think by the time you guys go to college, it might be a big thing. That quantum computing might be a good specialization to have in computer science. Quantum computing is essentially computer science, computing power, right? You're computing something to get some results, right? So quantum computing is closely linked to data engineering, closely linked to AI. That I can give you an example. So one of my friend works in a company where they build a bot to sort of automatically test your application, right? Now for him to, after he creates the model, for him to train that model, it takes 7, 8 hours for the model to just train on the data, right? So quantum computing really helps. If quantum computing comes into place, that 7 hour training can happen in less than an hour, right? So that is quantum computing. It is essentially reducing time. So a lot of things are happening around quantum computing, but right now it's not widely used, not commercially used. Just maybe Google or IBM sort of uses it for really big research purposes. But probably, by the time you guys go to college, I think it might be something quite interesting. The other thing I think is bioinformatics. So bioinformatics is also a big thing, like I said, healthcare. Because bioinformatics is essentially software which deals with biological data, right? So your biological data is much more different than your numerical data, which is mostly used in computers. So bioinformatics, which leverages biological data to build things around healthcare, like your gene mapping, DNA stuff, and everything around those kind of stuff. So I think bioinformatics is also, I think, a good stream, probably, which will come out when healthcare sort of matures into the technology side. Now coming to the China question. So see, China has been really ahead in terms of technology advancements, right? So we also talk about this a lot, and they've been really focused on building really great products in a very small amount of time, right? And I think that the biggest reason why Chinese tech companies are very successful is because of the penetration of internet users in the country, right? If you talk about India or any other sort of developing country, the penetration of internet is not so much. But in China, every other person uses a smartphone, and not just for your WhatsApp and communication or social network. They use it for all kinds of services. They use it for financial services, transportation services, and all these kind of services. That's why China has been much ahead in terms of internet adoption, and that has also sort of looped into building really great companies. And there's a thing that we spoke about. Why are Chinese so ahead in terms of building tech products? And one of the guys who's very senior said, it's because they work 6 hours a week. I mean, sorry, because they work 6 days a week. So the whole world is working 5 days a week, 4 days a week. They've been working 6 days a week for the last 10 years. So that is why they've been able to put out a lot of amazing things. But yeah, but it's mostly about the internet penetration in China, right? So in China has internet businesses become really big there, because the number of people who are on the internet there is really big. So yeah, I don't think they'll take over the world with AI, but they really build good technology products, definitely.
Thank you, Rohit. I think since you talked about bioinformatics and healthcare, um, very recently all of us have gone through two waves of pandemic of COVID-19, and we observed that in many cases there were instances when doctors were so overwhelmed with so many cases, right? I mean, that revealed the vulnerability of healthcare in across all over the world, not only India, US, Europe, everywhere, right? And I mean that just shows that as a healthcare industry is not equipped uh, to adapt to such quick changes. But maybe if there would have been a technology, they would have been able to handle it much more. For example, if there's a city which has 1 lakh people and it has only 100 doctors, how can technology help them and there are suppose 10,000 cases, or maybe one, like in during pandemic in India, like almost everyone got sick at the same point of time. So how can technology be used to to deal with such a healthcare disaster? I mean, if you could address that.
Yeah. I think the pandemic was a very challenging event for healthcare, but healthcare in general, like you mentioned, right? The World Health Organization says that for every one doctor to 1,000 patients is the ideal ratio for any country, city, or state, right? So, but in most countries that is not the case. It is very off, right? We don't have one doctor for every 1,000 patients. And there's a lot of talk in the healthcare side about how can technology drive or solve this problem, right? So I'll try to tell it in a very simple way. So essentially, a major part of your healthcare happens when the doctor is triaging. So triaging, what I mean is, let's say you have a fever or a headache or some kind of a body pain. You go to a doctor, and a doctor is essentially a data analyst, right? A doctor is analyzing data that he will check your temperature, he will check your pressure, he will check 4 5 things, and 6 7 things, and then depending on his experience, he will arrive at a conclusion, right? So a lot of triaging happens, right? A lot, and then he'll recommend probably some medication, or some changes in your lifestyle, or whatever it is. But this is based on some analysis he's doing, and there's a lot of talk around if technology can help in this process, right, in this first level of triaging. So I'll give a very simple example. All of you, I think many of you and your parents use Apple Watches, right? Apple Watches is become such a popular wearable right now. So Apple Watch, I think Apple can get into healthcare like much more deeply, right? Much more deeply integrated into our lives. Like let's imagine a scenario right now in Apple Watch. It can calculate your heart rate. It can tell you how well you're sleeping. It can tell you how well your activity is, etc. And now the new series has ECG and all of this stuff. And now with wearable technologies, there are many things which are coming out, which is like real-time glucose tracking, real-time sugar tracking in your body, real-time cholesterol tracking. So let's say there is a scenario where your Apple Watch is constantly understanding all the data related to your health, which is happening on your body, right? It knows that, let's say it says, hey Ashutosh, you've been having high temperature for the last 2 days during this time. You've not been able to sleep well. and your heart rate is a bit unstable, right? So maybe you should try looking at a doctor, right? Or maybe you should try going for a doctor. Or let's say even Siri becomes that smart in the future that Siri herself is able to recommend, or Alexa is able to recommend that, why don't you try this medication, or why don't you go for a walk at this time, or why don't you have a run at this time to see what will happen to your condition, right? So I think that is where it is heading, where technology, or something like Apple, which has wearable technology, which is deeply integrated into your lives, which can take care of your first level triaging process, right? Because these kind of data can be analyzed by wearables or very simple technology devices itself. You don't necessarily have to go to a doctor, right? You can go to a doctor after a point, right? So I think that will add a lot of value, in terms of healthcare, and also in lifestyle changes. It's becoming a big thing now. A lot of people are using Apple Watch, in that direction. And yeah, I think healthcare is going to be I think healthcare is going to be very, very big. I think a lot of things can happen around healthcare. Even if you talk about developing countries, right? In developed countries, it's a very common practice that people go for health checkups every year. And a health checkup is essentially data collection, right? They collect data on you, about you, on different elements, right? In developing countries, people don't really go for health checkups every year, and that data collection is sort of broken. And there are many scientific studies that proves that heart attacks can be predicted 5 years ahead, right? 5 years before it happens, and even cardiac arrest can be predicted 5 years before it happens. All this through regular health checkups, regular data collection, in a way, right? So if, let's say, our devices know about our health records, know about everything, then our devices and technology can predict this much, much earlier, and improve the lives of people, right? Improve the lives of people in general. So that is what it is. I think 100 years back, the average lifespan of man was about 40 to 50. Now it is 75. And I read a lot of science fiction books. I'm a big sci-fi fan. And they say that in 100 years, the lifespan of man will be about 100 to 120. And it will be a very rare instance when somebody dies from an illness. People will only die from old age or accidents. People dying from illnesses and diseases is going to be a very rare occurrence. I hope we get there. But I think technology will play a major role to take us there. Definitely.
I think that's a great answer, Rohit. I think one question I would like to ask you is related to, given that you just told us, gave us a glimpse into the future, what healthcare could look like. I mean, if we try to imagine, given that in next 20 years we'll be such a huge population, and if trying to imagine everyone using technology, how do you think imagine, so there are some companies which are planning to have a fleet of cars where you're not owning any car, and they are controlling. So basically I'm talking about an autonomous vehicle, basically. And how do you think system like that can be controlled, or technology can be used to control such systems?
Yeah. I think so. There's a concept of singularity, which is very, very wide in the technology space. Right? Singularity is a big concept, and I think there are many questions coming up. So I think we should look at some questions as well here. A lot of people asking things. I think people asking healthcare. Will technology help healthcare? Yes, I mean, definitely. They're asking, are all these things true? Yes, definitely very true. I can assure you that Apple is actually working on this. Apple is actually working on predicting heart attacks. They are actually working on predicting cardiac arrest. It is happening as we speak, right? And it is because of the data which is coming from the Apple Watch, which people are wearing. And it is going to there are more devices which are coming up. There is actually a device now which you can actually stick as a patch on your hand, which will tell you real-time glucose levels. So these kind of innovations are happening, and IoT devices which are collecting data and based on your health. And with data, you can predict things, right? All you need to predict things is data. And once data collection is in a very good state, then you can predict anything. You can predict cancer, you can predict heart attacks, you can predict any kind of health ailments which are going to come in the future, and you can take preventive actions, lifestyle changes now itself. I mean, there are many companies which are actually starting to do this, but I think we are still at the first level. It will take a couple more years, but I think we'll get there. In terms of singularity, right? I think what Ashutosh asked, singularity. So I'll tell you what singularity as a concept is, right? So let's say that I am, I am here, and the problem with data in the technology space is it's very distributed, right? So let's say I'll give you a very simple example. I am living in Bangalore right now, and I am not well. So I've been going to a hospital near my house for the last, let's say, 10 years, right? So they have my complete history, medical history for the last 10 years, right? So they know me. When I go, they already know what kind of problems I've had in the past, what kind of problems, what kind of health tests I've done. They know my body. They know, they have a medical history of me, right? So now let's say that I plan to leave town. I got a job somewhere else. I go to Delhi, or let's say I even leave the country, right? So when I go there, now obviously something happens to me. I will visit a new hospital, right? And that hospital does not have any data or has no history of my medical records, right? So these are the kind of problems which exist in the market right now, right? So, you know, if there is a if what I'm talking about is singularity, right? If there is a single system which manages all your health records, which any hospital can access, which any doctor can access when he is sort of talking to you or consulting with you for healthcare advice, that will add so much value in people's lives. Like it will improve the lives of people, because it doesn't matter which hospital you go to, everything goes into one system, let's say one cloud system, which can be accessed by multiple healthcare establishments or multiple healthcare providers to provide better value. Because they when as soon as you enter the doctor consultation room, within the doctor within a few clicks will know your complete history. When have you fallen sick, why did you fall sick, what medication did you take at that time, what medication worked for you that time, what medication did not work for you that time, everything, right? So that is the concept of singularity. I think we will get there, probably not now, maybe by the time you guys are 25, 30, I think it will be there, right? I think especially with healthcare, singularity is going to happen in terms of data and sort of visibility on data with other people. Now in terms of autonomous vehicles, right? I think everyone, you see Teslas now, self-driving is happening. You don't have to drive, you just put it on self-pilot mode, and the car sort of drives. If you have to talk about these self-driving cars, the technology is actually image processing. Okay, so there's no motion sensing, there's none of that. So Tesla or any of these cars which self-drive, they actually have a system inside them which actually captures images every millisecond, and then what they're doing is they are processing images to understand how the surrounding is, and then they are giving actions to cars, right? So that is actually what the concept of self-driving cars are. Now if you have to talk about this in a wider perspective, right? Let's say 10 years later, right, every car in, let's say, a state is self-driven, right? We don't have to drive. Let's say I will call through my mobile app, I will call a car, I will go sit in a car, and the car automatically takes me to office, and all the cars in the road are driving automatically, right? To do something like this, you need singularity, right? You need one system, right, which is controlling all the cars. It does not matter if it is a Lamborghini or a Ferrari or a Ford or whatever the car is. The brand of the car should not come into this divide, right? Because then if there is one system, one singular system which is controlling all of these elements, then everything sort of goes into one sort of flow, right? Everything, there'll be no traffic jams, your travel time is optimized, no accidents, nothing, right? So these are kind of thing, like, I mean, it's very futuristic, but these are kind of things which technology and the singularity concept can drive. And now singularity concept is coming in a lot of things. Like even if you see Amazon now, Amazon started with shopping, but then they went into grocery, they went into payment services, everything, right? So they want to do everything, give you everything into one service. So I think that is also how I think many things will pan out, I think, in the next couple of years.
I think that's great answer. I think a simple example that I can relate to is how we have lived. Right nowadays, when we have to go from one floor to the other, we simply use a lift. Right. I mean, I think if I'm not sure if people know this, but maybe 100 years ago, there used to be a lift man in every lift, and who used to take you from one floor to the other. I mean, kind of like a driver, but nowadays we don't need a driver for a lift, right? Just press a button
Yeah.
and you will reach your floor. I think
Yes.
it will be very much similar
Yeah.
in that way.
Yeah.
I think we have
Yeah.
a few questions coming in from young students who are asking, which language should I learn and how relevant will it be in the next, 10 to 15 years? Because I mean, most of the young kids are like around 15 years, like in next 15 years, they will be basically building products. for future world. So they're asking which language should I learn and how and will it be relevant in the future?
Yeah, I think this is a good question. I think a lot of people ask this. Which language do I learn? Any language I learn now, will it be relevant in the future? So one very plain answer: language does not matter, right? So the language. So how do I say? It is like writing a book, right? If you write a book, the concept of the book is what is important, right? It does not matter if you write it in English, French, Spanish, whatever it is. So language is just a medium for you to talk to the computer, right? So it does not really matter which language which you learn right now. It is just to understand the concepts. I think concept understanding, developing the logical thinking ability, right? That is what is most important, and that is what is valued in the market also right now. So I don't think don't be worried about language. I think Python is there. Python is a great language, very easy to understand. Start off on Python. Python is great. If I have to tell you about what is used in the market widely, Google still uses C, by the way, right? Google search still runs on C, C++. Microsoft still uses C for some of their applications. But widely used is, I think, Java, Python, some levels of JavaScript, and then Ruby Rails. But I don't think you want to get into it, because Ruby Rails is something that you can build things quickly, but probably not efficiently. Java is something which will take a lot of time to build, but you can build things efficiently. Python is something which is a mix of both, easy to learn, easy to build, has a lot of libraries, has a lot of capabilities to do. So it doesn't really matter which language you learn; it will not become irrelevant in the future. I can tell you an example. Right now, there's a new language called Golang, which is going on in the developers community. Right, a lot of companies are starting to build applications in Golang. Now, if you're in Microsoft, and let's say you're a Java developer in Microsoft, and Java decides that, okay, I mean Microsoft decides that, okay, now we are going to build the system in Golang. It's not like they're going to let you go and then bring some guys who know Golang. No, usually it will just take you a month's time to understand how Golang works and start coding in it. Because see, you guys have studied concepts, right? Loops, conditionals, right? So these are concepts which are critical, right? It's concepts which are critical. So language does not really matter, because you can write loops in Java, you can write loops in Python, you can write loops in JavaScript, you can write loops in any language, right? Conditionals also you can write in any language. It's just that the syntax might be different, the schematic might be different, but at the end of the day, the concept is what is important, right? If a requirement is given to you that this is what I want to make, this is a game which I want to make, can I break it down and build it conceptually? That is what is important, right? So don't be worried about the language. Whatever language you learn, be understand concepts for. That's why I think even in Codeyoung, the academics is more structured around understanding concepts, understanding fundamentals, right? Because that is what is important. Language is not important. If you write a book in English, and I come and say, hey, you know what, no, let's change it to French, right? The concept of the book still remains the same, right? Like the narrative or whatever, the concept of the book is still the same. If you have to transfer it to French, you can just Google the words and you can do it, right? It's as easy as that. And it's the same thing with programming, right? If you have a program, let's say a set of code in Python, and you want the same thing in Java, you can Google it and find out, right, how to do it. So language is not really important. Language is just a way to communicate with the machine or the application. But concept is what is really important. Concept and logical thinking is what is important. And even in your careers, if you ever get into computer science careers, early careers, coding sort of plays a role, but later in your careers, people mostly ask you about logical thinking. I don't know how many of you want to go to Google from here, but if you want to go to Google, they mostly ask you things around logical thinking. They want to know how you break down a problem and how you solve a problem, right? Coding is just a way to do it. And even if you're an engineer, any real life engineer you talk to, when a work is given to them, 80% of the time goes in, what approach am I going to do to solve this, right? What components will I build? What components should I write? How should I structure this to arrive at that final end state which I want, right? And coding is just 20%. 80% is just thinking about the problem, and 20% is coding. So don't be worried about the language. Like, try to understand concepts much better. I think that is what is valuable.
I think that's a great answer, Rohit. There's one more question from a very young kid uh, who's learning block-based programming, basically Scratch, and he was asking that, what is the point of learning Scratch or block-based programming I mean, is it even beneficial for me? I mean, what is the scope of this? So like I mean, I think what he's trying to ask is that like I'm like, most of the coding happens in text based, why am I learning block based programming? So what would you like to answer to him, and to all the other students as well who are in block based?
Yeah. I mean, like I said, right? Concept is very important. So Scratch and MIT App Inventor, I think, is a great product for you to understand concepts, right? In Scratch, you guys are using conditionals. You guys are using loops, right? So Scratch is essentially one block in Scratch is a text code, right? That text code is converted to a block, right? Now what in Scratch, what you guys are doing is you're learning the concepts of coding, right? So in coding, there are some concepts which are very, very important. One is sequential thinking, right? If you have to achieve something, if you have to get an output, you have to think in sequences. I have to do step 1, 2, 3, 4 to arrive at 5, which is my end state, which will give me that output, right? So Scratch really helps you to think sequentially, right? And it helps you understand concepts like loops, right? Loops is used a lot in Scratch. Conditionals is used a lot in Scratch, like if this happens, this, if else this happens, right? So those concepts are the concepts which you will learn in text-based programming also, right? So the young kids who are learning Scratch, I think when you guys start learning text-based programming, it's going to be very, very easy for you because you already know the concepts and fundamentals. It's just that the way you're writing the code, instead of using blocks, you are writing the text format for it, right? But at a very young age, that can be a little overwhelming, because some syntaxes might be a little complex. And also when you write large lines of code, debugging it, finding out where the issue would have happened, those kind of things can be a little draining, right? So I think Scratch is a good way for young kids to start off. They'll understand concepts, they'll understand this, and more or less, develop the logical thinking, right? Because what are you doing in Scratch, right? You take the Candy Crush game, right? I want to create Candy Crush replica using Scratch, right? You are actually logically solving the problem, right? The problem statement is, how do I create Candy Crush, or how do I think Among Us game, I think all of you guys created in Code Olympics, right? How do I create Among Us game? You are logically solving that problem, right? I think that is what is important. That logical thinking is developed, that to make this game, to make this character go from here to here, these are the set of things in sequential way which I should make, right? That is the coding thinking which you develop very young. And when you get into Python, or when you get into WebD, JavaScript, HTML, CSS, these kind of things will start falling into place, right? It's just that there you're doing it in blocks, here you're just writing text code for it. So I think Scratch is good. It's good. It's a good foundation to understand concepts. Even I play around in Scratch. It's a great product, right? It's a great product to understand concepts. And I think when you guys come to text-based programming, I think many of the things will start falling into place, and you'll find it much easier than people who've actually not done Scratch before.
I think that's a great answer, Rohit. Even I feel, I mean, a simple analogy that I can recall from this is that when we used to learn mathematics, we start with, learning very simple calculations, but we are learning those simple calculations so that we end up doing much more complex calculation in the future, right? So if we are in a habit of using loops and conditional to solve a problem, like creating a game, we in the future, when we come across a problem in our life, we'll be in a habit of using loops and conditional to solve a real life problem using technology. I think that's the practice that we want kids to get into, right?
Yeah.
I think we have a very interesting question from a student who has asked, how can IoT be helpful for construction stage of projects, for example, power projects and refineries. I think we recently had a IoT code talk as well. The previous code talk was on IoT, but yeah, I mean, if you would like to answer this question.
So IoT in construction, right? Yeah, IoT in construction. See, IoT fundamentally is basically I think we spoke in the last code talks. The internet of people. So right now we are in the internet of people, right? We are in a Zoom call. Internet is connecting people, right? IoT is basically internet connectivity between two devices, right? Now, for construction, how can it be used, right? It can be used in various ways. It depends on what kind of application you want to do. So there is a thing called contour construction. I forgot the name, but this was something I had in college. So essentially, in China, people are able to build buildings in 2 days, right? And this is done through robotics and IoT in a way, right? And basically, a plan is given, and they use some kind of concrete which sort of solidifies very quickly. But the completion and the optimization is done through IoT devices, right? You have devices which is measuring, like for example, construction happens in multiple layers, right? There is your foundation, and then you put steel bars for reinforcing and giving strength to a building, and then you add more elements to it, and then that's how you build up a structure, right? Now, how do you, like, you can actually put IoT devices there to give you data if your structure is ready for building up next, right? Usually people build one, then they wait for some amount of time, collect some data, then they build the next level on top of it. Now, if you really want to accelerate that process and build very, very quickly on top of each other, you need data, right? So to get the data of, let's say, how concrete is solidifying, or if your reinforcement is set, right? So these kind of things is, I think, what IoT can do in construction. And like, other than construction, just in maintenance of real estate, right? There are many things which IoT can do. I think it's used a lot now for power generation, and also for maintenance, and like understanding where damages in buildings are, right? These are the many kind of things where you just put a device which has access to the internet, which can actually read signals and then sort of give you alerts and give you data around what is going wrong. So yeah, IoT is a lot of things can be done with IoT. But fundamentally, the concept is that there is a device. That device can collect data, and that device can basically send data through the internet to you through a phone, or it can send it to another device through the internet, right? That is what it is. So how to apply it? I think that you can be creative on how to think about it.
I think that's a great answer, Rohit. I think that's how a lot of manufacturing industries will, I mean, I have started to work on, and will definitely be working on in the future, right?
Yeah.
I think uh, I think that's all the questions that, I mean, we have pretty much all the questions that have been asked. We have asked them in some other way, in maybe in an indirect way. Now, I think we have few announcements for Code Olympics. So far we had Code Olympics for students in Scratch and MIT, and but we have launched Code Olympics for students of web development and Python, and we will start all their events from this Monday, that is 4th of October. But all those students who have to all the students who want the extra points, so can register early before 4th of October and get those extra points. And on top of that, just a gentle reminder to all the Coding Carnival students who are in Scratch and MIT, that don't forget to submit your entry for Coding Carnival, and don't forget to give the quiz for your Code Dash, which recently happened. I think it was a great talk, Rohit. I'm sure a lot of students would have found this a lot of value in what we have learned today, and I'm sure we will be able to create more value and bring more value to the table in the next Code Talk. I think that's all for today. Thank you, Rohit.
Yeah, thank you everyone. I think just closing off, I just want to say one thing. I think building for the future, right? I think everyone should stay curious, right? And see, you guys are understanding how technology works at such a young age, right? Now, how do you use it is the big question. Like, I'll take a very simple example. You guys go to school every day, and in school, a lot of paper is wasted, right? Paper is wasted. Paper for examinations, paper for your class notes, textbooks, all of this stuff, right? But what is an examination? An examination is a question set which is created for a subject or a set of students, and then your students write stuff on paper and then submit it, and then evaluation. Like, the whole school system is wasting a lot of paper, right? And now, can you guys think of some technology solution for this? Of course, right? You can actually think of some technological way to solve this, right? So building the future, I think, have curiosity, right? Now you guys understand. You guys you're using Scratch, you're using Python, you're using all these languages to understand how technologies work, right? Now be curious, right? And try to have the mindset of problem solving and building experiences, right? Anything that you see that, okay, this is a problem, which I probably think that technology, if I do something like this in technology, it can solve this problem, right? And the other mindset is experience, right? See what kind of experience you can build for somebody. It can be your parents, your friends, your relatives, whatever it is, right? See how you can build that experience with technology. And I think that is how, the future will be built. So be curious, always be on the lookout, and all the best. I think it was great talking to everyone. Thank you everyone for joining. It was great talking to you.
Thank you, Rohit. Have a great day, everyone. Thank you.